In this video, we will see how we can able to subscribe the GOOSE message from third-party release to ABB make release. So in my case, I will take my P643 as a GOOSE publisher. So you can able to quickly see the ID details, which is a P643 transformer protection control IDs, and its edition to SCL revision 2007B. Also, you can able to see the 640 edition in the down by selecting the ID details section in the MCL file, which is the MyCom configuration language file format, proprietary file for the MyComic release. And you can also able to see the ICD template version, and dataset has been created by default when we add this particular relay. And you can also able to create a new dataset when you wanted to customize the GOOSE control block for your different projects. And the dataset has been connected to the GOOSE control block, and there are two different GOOSE control block defined, and you can also see it's fully configured without any problem. And maybe we can quickly validate other information has been already configured. So by selecting the validate configuration option, we could able to see the validation results, and there is no error, also warnings, and we are good to go. So let's export. Maybe I can quickly show you what are the dataset contents. So this is one of the dataset which is connected to the GOOSE control block instance. Basically, the protection trip start, also the quality data attributes has been added for different protection functions. Also the virtual outputs, those are basically the GOOSE GIO2 state value and the quality data attributes. And time tag is optional anyhow, so we just minimize here and select the tools section and export the configuration to SCL file format. So we will export as a configured ID description file format or instantiated ID description file format. Any one of them is okay. So let's choose this particular file format and choose yes and say yes here, and it will ask for the SCL schema version, and we could able to also see the SCL schema version in the ID details, and in our case it's version 3.1 for edition 2 SCL schema. I will also highlight how we can able to see once it's exported successfully to the right location. So now the MyCom configuration proprietary file format is converting the data to the standardized SCL file format, which is a configured ID description, writing the contents to the proper XML file format. Then we can able to just go to the ID details, and here we can able to see the SCL schema version, which is a version 3.1. That's why we could able to choose the version 3.1 while we export the SCL schema with 3.1. So we exported the configuration. Let's come back to the GOOSE subscriber side. So RAD670, which is our GOOSE subscriber in this case, by right-clicking the ID object, let's go to the application configuration. This is the step 1. We need to basically add the suitable GOOSE subscription function block. What type of function block that we need to choose depending on the requirement. We can able to pick the different type of GOOSE subscription function blocks. There are different type of function blocks like GOOSE interlock receive, GOOSE binary receive, GOOSE double point, single point, and many different data. Let's create a, let's go to the GOOSE, and I will just add, for the clarity, I will add another main application. Here I will call GOOSE from MyCom. Sorry, there should not be any space. And then here we need to just go to the left side where we could able to see the object type, and we can able to find the station communication. Under this we could able to see the different type of GOOSE subscription function blocks. So let's add the GOOSE binary receive function block. Just drag and drop in the middle. And we can able to say assign here. Let's maximize the middle window, the application configuration tool. After we insert the GOOSE binary receive function block, we can able to just say save, which is under the edit menu of the PCM600 main menu. After we save, what we need to do is we just need to enable the setting for the function block that we have added. By default it will be off condition, and we need to manually enable by selecting the function block after we save. And we could able to see the PCM plan structure. There is a new function block added. By right clicking the GOOSE binary receive function block, you can go to the parameter setting tool. There we can able to enable the setting, which is step 2 post adding the function block. So after you change the setting from off to on, we need to save. And let's come back to the application configuration. And here we're okay, and we can able to just say close. We don't want to work anymore here in the application configuration. Now let's add the generic ID object. So by selecting the bay level, you can able to go to the new hierarchy and then generic 620 ID and choose the generic 620 ID object. There we can able to provide the IP address of your ID that you can able to see. In this case, the IP address 192.168.210.129. So let's come back here to the PCM600 192.168.210.129 and just say next and finish. What happens here when we add the new 620 ID object and the hierarchy, based on the hierarchy, the substation and voltage level, bay level, and the ID instance will be created automatically. And which is not correct, depends on the ID object that we do add in the different manufacturer ID. For example, in this case, if we go back to the MyCom relay and the ID name starts with OMA 129, which is a technical key here in the MyCom relay, and there you go to the GOOSE publishing category and then double click the GOOSE control block, and you can also see the dataset reference for the GOOSE control block start with the ID name and the logical device, logical node, and where exactly the dataset has been connected to the MMS reference. And there you can also able to see the GOOSE identifier. Everything starts with the technical key followed by the logical device and logical node and the GOOSE control block instance. And what happens by default when we add the 620 ID object, it will create a standardized and technical key based on the PCM plan structure. And what happens when we right click as a next step and select the import option? Basically, we import the CD file, the CID file or IID file that we exported from the different ID configuration tool or system configuration tool. So here we can able to pick the file that we exported. So in this case, this is the file which we exported. Just say open, and here we need to say replace unknown ID types because it's not a PCM ID type, and we also need to select the PCM object type, and so that we could able to import successfully the third-party IDs. And the third-party IDs are unknown to the PCM plan structure. That's why we do choose the two options here. And you can also ignore the substation section because the substation section is not available in the MyCom relay SCL file that we have exported. And you can also include the ID name in the caption, and it's an optional. If you have the right ID name, you can also include by default. And let's say import. And here the problem starts. If you closely look at the import screen, there you could able to see the technical key will stay as it is, and it will not update based on the exported or the ID name that is available in the MyCom relay. That's why most of the cases the GOOSE subscription doesn't work when we connect the GOOSE control block from publisher to the subscriber and map to the signal matrix and connect to the function block. And the problem is the technical key as a source, and when you right click, and you can also say you can rename the caption later on, but anyhow we will be deleting this ID object. By right clicking the ID object that we imported, you can able to just say click the 650 configuration tool. There we can able to see the problem, why the GOOSE subscription will not work when we follow the default method, and what exactly we need to do, that we will do next by deleting the ID object here. So here we could able to see the GOOSE communication has been selected by default in the top and for the engineering purpose, and here you can able to see that there are two different control blocks, GOOSE control block, and it starts with a different technical key. Completely it's different than the MyCom configuration. So here you can able to see the dataset references totally different, and here it's completely different because it starts with a different technical key. It will be a mismatch when we write this configuration, mapping it and subscribing to the ABB relay, and ABB relay will not subscribe because we are doing the wrong engineering. And what we need to do is a workaround. Just close this GOOSE control block, and you can able to just right click the relay, and you can able to just say delete the ID object at this level. And right click the bay level, and then go to the new and select the generic 620 ID. Select the 620 ID object, and there you can provide the IP address 129, and then just say finish, and then you go to the MyCom relay MCL configuration tool. There you copy the technical key of your MyCom relay and paste the technical key here in the generic 670 ID object that you create, and you can also add into the caption, and you can also right click the newly added IEC 670 object, and then you can able to just select the import option. Now we try to import the SCL file that we exported, and we select the same option, ignore the substation section, and if you have the ID name correctly in the other manufacturer ID, you can able to just select, but in this case the description is not really correct, so model 3 doesn't make any sense. That's why we didn't check that particular box. Otherwise, you'll be able to see model 3 here in the caption, which is not that much clear. Anyhow, we will be changing it later on. If you have a right caption description, you can able to enable that particular option also for right ID. And somehow it also updates, which is a surprise here. We'll change it for our clarity. And we right click the relay now, the 620 ID object, then open the 620 configuration. And here we should be able to see the right GOOSE control block reference, similar to the MyCom configuration language description or the setting information that we build for the MyComic relay, which is our GOOSE publisher in this case. So here we could able to see the reference, the GOOSE control block start with OMA 129 system. We can able to verify here and slash the reference is correct. And we can come back here. And we basically wanted to subscribe one of the GOOSE control block. We can able to just select source to destination. So the destination ID name we can able to see here, the RED 670 D1Q0 to A1. So select the publisher, and this is the GOOSE control block and where exactly we wanted to subscribe. So you can able to just enable here, and you can able to see there is a tick mark came, and you can also verify the different set of GOOSE control block parameter that you define in the MyCom configuration language file. So you can also subscribe more than one if you configure the GOOSE control block correctly. You can able to save as the next step. And then we can able to just say close at this level and right click the RED 670 relay. Then you go to the signal matrix, which is a manual way of doing the GOOSE engineering. There is an alternate method, which is an easy goosing option. I will cover that particular topic in another video to make the GOOSE engineering more easier. So here we come to the GOOSE receive function block, and we also need to know which instance we have added into the application configuration. So you can also able to expand so you can just say here the instance number here is 2, so we could able to see the GOOSE binary receive instance 2 here. So here only we need to subscribe the GOOSE control block. These are the publisher information, so these many informations are available. So let's subscribe one of the GOOSE JVO indication, and we will subscribe to instance number 2, and then again let's subscribe 3 different inputs. And you can also subscribe a different protection status as well, the protection start and trip. That's also easy for us to simulate, and just say save at this level. For example, I will only subscribe this 3 state value, and we will close the signal matrix and come back to the application configuration. The main page of the different application function blocks are getting loaded. So basically subscribe to first three different inputs, so you can able to write to the real ID, and more importantly we also need to enable the 650 setting in both IDs. So in the ABB maker relay, so you can go to the station communication. There is a 658-1, which is an MMS communication protocol. There you can also see the setting, which should be on. And then if you're using edition 1, and then you can able to see the port selection. If it is edition 2, and you can able to just right click the relay. If it is old model ID, you need to know which port you're exactly using for GOOSE publish and subscription. And you can able to right click the 670 ID object and then go to the Ethernet configuration tool for 2.0 above IDs, where we manage the different services. Those are related to MMS, GOOSE, sample value. So here you can able to see the station bus, and I have enabled the GOOSE protocol on this particular access point, so that it allows to subscribe and publish the GOOSE message on that particular access point. So we have added the signal. You can even able to expand the output for connecting to or extending to another function block for different functionality, like shipping, interlock, special protection, event triggering, many different applications that we can able to achieve with GOOSE message. And let's try to create 3 different signal, and the validity also comes in the down, that we can also able to use it for getting the alert if you are using edition 1 ID, but if you are using edition 2 latest model ID, you can able to get the subscription monitoring with the LGOOSE logical node with the latest version above 2 to 4 IDs. So let's close this level. And then we need to write the configuration that we built, and then just say write to the ID and write to the real ID for the GOOSE subscriber. And in the publisher side, I do not have the real ID with me. What I can able to do, I can able to use ID score to make sure that even if you have a real ID as a GOOSE publisher, in some cases you may have a problem. Maybe you follow the first step and you wanted to make sure you did the proper engineering. If you want to find out the root cause, why it's not exactly publishing properly in the real network, then you can able to use ID score in that case to make sure where exactly the problem, or you can able to easily find the solution by simulating the GOOSE control block with ID score in a quick time. From the publisher side, it's also important, once you enable the GOOSE control block, for example GCB01 and 02, it's important to enable the GOOSE control block setting that you can able to see from the IEC 640 configuration, and there you can able to see GOOSE enable option. This should be on, and for example if you enable 2 different GOOSE control block, you need to enable from this level and say okay, and then write this particular setting to the real ID, and the MCL should be written to the ID and it should be in active bank. And it's also important to define the unique multicast MAC address and the other GOOSE control block parameters unique in the system wide. The configuration is almost going to complete. Meantime, I can able to open ID's code on my PC. It's also important to use the latest version of ID's code, version 5.11, to get maximum benefit that we have added to the recent versions. So the ID's code has been opened here, and you can able to just go to the simulate ID section. Then you can able to pick the CID file which has been exported. Then you can able to import it. You can able to pick only the ID object, so IMA 129. And if you only wanted to check the GOOSE control block verification from ID's code by simulating it without simulating the 6150 server, it's also possible. We have complete flexibility for only publishing the GOOSE control block. So SCL content has been loaded, and we can able to just go to the start screen. And it's also important to define the right network adapter, where exactly we wanted to simulate. So I have the Intel Ethernet connection, which is my inbuilt Ethernet access point network adapter. This is connected to the GOOSE subscriber network, so that whatever we are simulating from here, it goes to the network, and the subscriber will be able to subscribe the message. And by selecting the GOOSE control block section in the ID navigation pane, you can able to select the services section. There is a GOOSE configuration option, and there you can able to pick the dataset from this level, and you can able to also expand the retransmission strategy, and you can also control this value. By default, you can able to keep it same. To check, so let's go to the GOOSE subscriber. So the configuration has been written to the ID, and right click the ID, and let's go to the application configuration to make sure there is no GOOSE messages are received, because there is no real ID and there is no GOOSE messages that are available in the network at the moment. So what we're going to do is we're going to use ID's code to simulate the GOOSE message and verify whether the GOOSE messages are properly subscribed. Basically, we are trying to validate the GOOSE control block that we configure in the MyCommit relay. So you go to the main application, there where we added the GOOSE binary receive function block. So here we go. The function block is here, and you can able to just expand it a bit in the left so that you get the proper visibility of the function block. Let's go to the online monitoring. So there is an option under the help menu. There is a work online. So you can able to select the function block where we wanted to monitor online. So here we should be able to see there should not be any quality signal validity that should be received here, because there is no GOOSE control block active for the subscription that we did here. So online monitoring is getting started now, and the real values are getting updated. So let me go online. I switched my screen to another screen. That's why the online monitoring got disabled. Let's go online again without disturbing the active screen. So when we go online with the real ID, the screen should be active. That means we should not go to another window or another tool simultaneously. Let's go back here and then again I will try to go online. So now exactly it's going online monitoring. Values are getting updated and we could able to see 0 in the validity. That means there is no active GOOSE control block in the network. And communication validity also 0. And let's come back to the GOOSE control block that we have in there. So we can able to uncheck the simulation bit because the ID is in normal condition now. We can start publishing the GOOSE message now from the ID code. And ID code now started publishing the GOOSE message, and we can also able to monitor that from the sniffer section by enabling it, so that whatever we are simulating, you can also monitor in the sniffer tab. It's like in Wireshark, you can able to get more insights than Wireshark because we have the SCL file loaded. You can able to have the filter option. There are so many other GOOSE control blocks are available in the network. You can able to filter very well which ID you are exactly simulating it, and the event that has been included in the GOOSE control block, the different messages. Let's come back here and I will try to go online now because we switched the screen. Again, we need to go online to the real ID. Go to work online option. Take some time to go online. It's connecting it now. And now we could able to see the validity as 1. That means there is a GOOSE control block available and communication validity also should be 1 now. Then yeah, we can able to even change the value here. Let's go to the simulator section and let me change some of the value for the GOOSE control block. For example, in this case, I will change the GOOSE GJO to indication 1 and indication 2 state value to true and update the status and come back here. Okay, this is normal because the client is not active here. We are switching the screen by selecting it. Let me zoom in a little bit to make sure you could able to see the validity, also the output. Now we should get the output as well on top of the validity of the communication. Let's go online again. So we need to select the function block first, then got selected. Then you go work online so that the function block will be connected to the real ID, and we should be able to see the values which are published from the ID's code as a GOOSE simulator or GOOSE publisher by importing the publisher SCL file content. So we are simulating the state value 1 and 2, so you can able to see the output are received here for the input 1 and 2, and you can also see the output also high and the validity also high for the input 1 and 2, and 3 should not be active, the output, because we are not simulating the output of 3. And communication is validity, and this is how we could able to use ID's code to check such a configuration. And if you want to test the real ID which is energized, you can also enable the simulation flag enable, and you can able to come back to the ID's code, and you can also just go to the browser section. You can able to connect to the subscriber ID in 25. You can able to discover, so you can basically parallelly use both functionality. So you can able to simulate an ID, both MMS server can be simulated, also GOOSE control block as a GOOSE publisher, you can able to simulate from the simulator section, and in the browser section you can able to use ID's code as a 640 client, just like discovering the ID. You can also import the SCL file and connect, and you can able to just go to the data model, and there is LLN 0, and then there is L, and there you can able to see always enable the description. System LLN 0, there you can able to select the LPHD logical node, and you can able to see there is a simulation data object. You can able to make it enable in case if you would like to simulate the GOOSE control block with simulation flag enable, so that the real subscriber will accept the simulated GOOSE messages with the simulation flag enable. This advanced use case you can able to even try in the real substation, and you can also practice it. So this is how we need to subscribe the GOOSE messages from third-party IDs to the ABB make relays. That's all in this video. In case if you need any support related to simulation of IDs and discovering the ID as a GOOSE publisher or subscriber to validate, and you can able to feel free to contact the Omicron technical support. We'll be happy to support you. You can also reach the technical support email address from the technical support section. There you can able to see the different support line emails. Depending on the location, you can able to choose the right support line email, and we will be happy to support you with the right solution to make your testing more easier with ID's code and many other 603 sub-basic code testing solution.